Welcome to, let me think. I think it's number six. Number six in Ask Tom office hours, the DBA session. I've probably look a little bit ragged, look a little bit dopey because I've been overseas for a while doing some very hectic things, but I've had a fantastic time doing it. And thank you very much for joining this office hours session. The whole office hours thing is something I'm super proud of. I was talking to some of the delegates in India where I was last week. And by my count, we've done over 80 sessions since we launched the program at the start of February. So it's 80 hours of basically free Q&A, content, education from all the different product managers inside the Oracle organization. And particularly, there are people in the Oracle organization like me whose primary job it is to be outward bound, to see the rest of the community, etc. But there are lots of incredibly intelligent, bright experts inside the organization that are obviously just flat out dealing with the technical composition of the products they look after. So to have those people now becoming available to you on a monthly basis is also awesome. So let me share a different screen now. And what we'll do is talk about what our agenda is going to be. So hopefully you can all see that. First of all, before I talk about our agenda, I'm going to talk about some bits and pieces. Now, what do I mean by bits and pieces? The first one is this. This is where I was last week. I was at the ODevC Yatra Tour, formerly known as the OTN Yatra Tour, but obviously with the focus now being on more of a development sphere of side of things, we've moved on to ODevC, Oracle Developer Community. Now, I said this on the tour in India as well, and I'll say it on the office hours today. Whenever, it's funny that I'm hosting a DBA office hours, and yet I quite openly say the focus is now developers. There's a very good reason why I say that. Number one is I think that separation is just an artificial separation. I think that has got to disappear. I think the reality is everyone is a developer nowadays, in the sense of everyone builds or develops things to make their businesses more successful. Now, I don't care if you're a DBA that just looks after the backups or manages the performance tuning. The reality is your focus is still on business success. You're delivering and developing customer success. So this is one of the discussions I had in India with various delegates. They're saying, are we ignoring DBAs? I don't think that at all. I think we're understanding that it's always been the case that all IT professionals should be focusing on building customer success and developing customer innovation, customer solutions. So I have no problems with calling it ODevC Yatra. I have no problems with our rebranding as Oracle Developer Community, because I think we're all in the development business, the ability to build solutions that work well and perform well. And obviously that's more the DBA frame of things to make sure our customers are success. But anyway, so this is what I did in India. I went to 5 of the 7 cities there. Some of the more dedicated speakers went to all 7, but it was an absolutely hectic 7 days. We generally would take off for the venue sort of just after breakfast in the morning, sort of around about 8 o'clock. We'd speak all day, talk to the delegates, have thousands upon thousands of selfies, and then we'd literally go straight to the airport, jump on a plane, hopefully get to the next city before maybe 1 in the morning, and then we'd wake up again and do it all again. It was a fantastic event, but I just wanted to mention it in tonight's office hours, because if you want to have some fun, go to the URL there, tinyurl/ODevC Yatra. Now, it's not slides, it's not content. It's a little YouTube video I made on the bus ride we made between, I think, Pune and Mumbai, about 4 hours or so in the pelting downward rain, all of the speakers crammed into a bus. Now, admittedly, we maybe had a couple of beers, but I thought it was a great way of showing what a fantastic way it is to build community just by either being a speaker or being an attendee on these events. I was in the bus, and although I'd met the speakers obviously during the day, some of these people I'd never met before the India event, that week-long event. And so you make fantastic friendships, you make great contacts, and you build your community just by being either an attendee or being a speaker. More so if you're all crammed into a bus for 4 hours talking about horror stories from the day, but as you can imagine, it's a great way, even if you're doing talks to your user group, for example, to build community and grow the Oracle network. Now, just one last bit of self-promotion. Having moved on from the Asian continent, time for a brand new continent for me, and that is the Latin America tour that's coming up. I'll be doing 5 cities, Santiago, all the way through to Lima in Peru. So if you're any of those 5 cities, please come along to the events. You can get from the website there. Please come along, say hello. I'm hoping to network, obviously, with a brand new bunch of speakers. I'll try to touch up on my Spanish because that's currently non-existent, but hopefully you'll all have a wonderful time if you're in America. So these are the questions that have already come in for this office hours. Hopefully we'll get to them all. I have some doubts because I always promise that every month that we'll get to them, and then I always pull up short and end up a bit red-faced, but we'll see how we go. So these are the questions. So one of the things, we had a lot of fun on this Indian tour. We ran what we call a quiz night, or effectively a quiz at the end of the day, where we sort of tested people's general Oracle knowledge with some technical questions, occasionally some fun questions and some fairly lightweight questions. But it was a good mix and a great way of getting people to relax at the end of a very, very hectic day of content. So I'm going to talk about one of the quizzes that had a few people challenging me on it, saying, no, I think your answer is wrong. But I'll hope to set that straight because it's an interesting thing to talk about. The other two, the first two things we talk about they came out of this week. And so I was promoting this tonight's office hours session during the week in India. And one of the things that came out was, yes, you've given me some cool 12.2 and above features. What if I want to achieve the same thing before I get to 12.2? Because some of us haven't upgraded. And one of those things was moving a table online or doing some sort of database organizational maintenance and not having to disrupt the users if possible, or keep the outage as small as physically possible. And the second one was dropping indexes. When is it safe to drop an index? Similarly, we'll talk about this tonight. I gave some information about how we've made things easier to look at in 12.2, but as was a common theme, I'm not on 12.2 yet. How do I achieve that at the same time? This is a question. The next one's a question from actually last month, which I promised I'd get to this month. And that is public versus private synonyms. Just a very simple question. What's the difference between them? And what are the privileges associated around using those synonyms? One that came in just the other day was how to bypass forced logging. So we'll talk about what forced logging is, what's the motivation for it, and what are some of the options if you want to try and maybe get around it without damaging the database. We'll talk about a new privilege called inherent privileges, which came in Oracle 12 and really is about handling a security risk, which not many people are aware of. This one came in came in just this afternoon, how to prevent archive logs being removed when you're doing a flashback database. And I'll expand upon why archive logs are important when doing a flashback when we get to that. And the last one that came in so far was handling performance issues with ADR block file reads. I hope we can get to that, but I'll do my best. Now, it's funny, these first three are what I call the yeah, but, because each time I talk about these in India, someone said, yeah, but I'm not on 12.2, or yeah, but I don't think that answer's right. So that's the first one we'll cover off, and hopefully those who are in India and obviously the general audience here will get some value in that as well. So let's talk about the ROWNUM quiz. As I said before, we had a lot of fun in India. We had this quiz at the end of each night or end of each day. And what we would do is we'd ask questions with multiple choice answers, and the whole audience would start standing up. And so I'm telling you this because you can do it in your own organization or your own user groups if you're a member of one. They're a lot of fun. You get the whole audience standing up, and then we present them a question, and they have to, with a gesture, indicate their answer. So you can see the question here was, select star from scott.emp where ROWNUM between 2 and 6 will return how many rows. And if you thought it returned, say, 5 rows, you put your hands on your head. And if you thought it returned 6 rows, you would cross your arms. And if you thought it would return no rows, you'd put your hands on your hips. And so everyone would make their gesture. And in just about every single city, whenever we asked this question, it just wiped out the people in terms of which ones would actually get it correct, because very few people chose the answer of no rows. And the question is, why would do that? Why do people come up with none? Because for me, I thought it was actually fairly obvious and I thought it was well known, but the fact that so many people didn't get it right suggests that it's worthwhile talking about this evening. So the question is how? Whenever we deal with ROWNUM, surely we should always get some rows. So let's have a look at why that is the case. Here is a simple query, which almost leads people into a false sense of a trap in terms of answering this question. I'm doing select ROWNUM followed by all the actual columns from the employee table. And as you can see, as most people are fully aware, the ROWNUM simply starts at 1 and goes 1, 2, 3, 4, 5, etc. And so as a result, people tend to think that that row number is some sort of preordained or pre-known constant that's actually almost, you can think of it almost being stored out on the database somewhere. I've done my best to draw those rows scattered across a database data file. Now, we might know that's not the case. We might know that ROWNUM is actually a pseudo column, so it doesn't actually exist on the disk. But people still have this mindset that when I run a query, that the result set automatically has this sort of interpretation of the rows that will actually be coming back. But let's look at actually how ROWNUM is actually derived and why the answer to that quiz question would actually be 0 and no rows. So let me do a select ROWNUM e.star from scott.emp. And obviously the first thing I'll do is I'll encounter the first row on that table. What'll happen is we said the employee number there is 7369 and it's Smith. And what do? We say, okay, does this row, so let me take a step back. I'm stressing I'm not actually putting the output yet onto the screen. I'm sort of mimicking the database decision-making process. I've picked up a row from a block and I'm looking at it. And the first thing I say is, does it satisfy my criteria? Does it satisfy the criteria for actually presenting back to the user? Now, there's no where clause on that select statement. So it, by definition, will satisfy the criteria. If it satisfies the right criteria, then we say that is the first row to satisfy my criteria, and we assign it ROWNUM equals 1. ROWNUM equals 1 being the first row to satisfy my criteria. Let me now move along to the second row, which is 7499 of Alan. Does it satisfy the criteria? As we said, there's no where clause. Yes, it does. So it becomes the second row to do so. Oh, sorry, someone threw on the chat line. I got someone saying they can't hear me. Can everyone else hear me? Please scream out if you can't.
You bet, Connor, we can hear you.
Cool, no worries, thank you. If it's a case of you not wanting to hear me, that's different. That's a different thing altogether. But if you can hear me and you're choosing to, excellent. So as I said, that is the second row to do so. And therefore ROWNUM equals 2. So a ROWNUM is assigned conceptually on the successful application of predicates. Did my row successfully pass all the where clause predicates? If it did, yes, it's going to come out, and that's going to be assigned of 1, 2, 3, etc. So let me now return to the quiz. The quiz was select star from scott.emp, where ROWNUM between 2 and 6. Let's fold through that same process that the database is doing to see what happens as we encounter each row. So I pick up the first row, and rather than using the term ROWNUM, I put that column saying it's the potential. It's got a potential ROWNUM of 1 because it is the first row that I'm considering. Now, does it satisfy my criteria? Well, any potential ROWNUM is going to be a value of 1 because it's the first row. What is my criteria? My criteria is between 2 and 6. No, it doesn't satisfy that. So what do? It never comes out of the result set. It gets discarded. And I move on to the second row. So we discard that row and move on to the second row. The second row is Alan, 7499. Now, how many rows have I got so far back from the result set? Well, none. So its potential ROWNUM is 1. Even though it's the second row we've encountered, it's only the first potential row that's going to come back to our result set. So does it satisfy the criteria of ROWNUM between 2 and 6? Well, no, it doesn't. We discard it from the results. And as you can see, as we continue on through that, the same logic will apply for every single row. We'll discard it because they all get a potential ROWNUM of 1. We never ever get to ROWNUM equals 2. And as a result, we end up with no rows selected. So hopefully that helps those people that were a little bit confused when they were doing the quiz in India, or anyone else on the call that is actually unsure of how ROWNUM is assigned and why sometimes they might get spurious results. I see my friend Scott was having troubles with audio, but he's Australian. You have to forgive him. Okay, let's move on to the second one. Online table move before 12.2. Now, before I do that, let me do a recap on why online reorganization is super, super cool in 12.2. Just to sort of hopefully whet your appetite in terms of encouraging your managers and that to get on the upgrade bandwagon. So in 12.2 and above, you can pretty much do online everything. Now, as I said in India recently, every time a new release of the database comes up, there's normally some Oracle bozo who gets up in front of a stage or on a webinar like myself and says, everything can be done online, every single thing. And we generally then would go ahead and list all these caveats, except when you've got this, except if you've got that, whatever. 12.2 is probably the first one where I am like super confident. It's amazing how much stuff you can do online. I have a lot of fun. I do my best to try break it. I try to come up with really bizarre scenarios to see if I can break the online operation. And I found some, but it's hard. It's really hard to do. Let me give you a couple of examples. The first one is the one that most DBAs have been waiting for decades. And that is a simple requirement. Can I move a heap table online? Moving an index organized table online came along in 8.1 because effectively under the covers, it's an index. And that's when we've been able to rebuild indexes online for some length of time. But here's an example. Here's my heap table, create table TS select star from DBA objects. I've got an index on that table. Let me get some active transactions on that table. So the blue indicates here a separate session. I'm doing some active transactions and they're not even committed yet. And then I do alter table T, move online in my first session. Now it will commence. It won't take any locks. It will commence and wait for those uncommitted tractions to complete. And when they do, the alter table T moves online. It completes successfully. There was no interruption to service. And notice there, if I do a select from user indexes, the index actually never became invalid as well. So we kept the index valid, we kept the table accessible to all customers during the modification, and we managed to do our move. That's a really good thing in conjunction with things like attribute clustering, which also came in at 12, in terms of if you want to cluster the data. We spoke about that in a previous office hours session, so I won't go over it again tonight, but the ability to move data around to make it better for performance in terms of queries. It used to be the case that you might want to reshuffle some data to make it better for performance, but you couldn't because you either had to take an outage, but now you can do it without taking an outage. And things, I got challenged in India along the lines of, well, that's all great, but what about more complicated tasks? Well, we can do composite operations in 12.2. I could take this sales table, I could move it, I could compress it at the same time. I could take maybe two of the existing indexes. They could go to brand new table spaces. Let me clarify. It won't create the table spaces as part of the operation. You need to pre-create them, but I could move the indexes from existing table spaces to another. You can see I'm moving the sales table maybe to a brand new table space as well and compressing it, and it all just happens online. This is the one I really like. As databases get bigger, and who's got a database that gets smaller nowadays? Like nobody. All databases just get bigger and bigger and bigger. I might need to migrate a non-partition table to a partition table. And I've been giving this example for a long, long time as a proof of just how much you can do online. So here's a table called T. It's 20 copies of DBA objects. It's got a couple of indexes on it, on object ID and created object name. But I could do all this in one command. I'm going to modify the table. I'm going to partition it by range, and I'm going to use interval partitioning as well. And I might compress that oldest partition as well. So I'm trying to dial up the amount of complexity here to see if I can break the online operation. Then I'm going to update the indexes. One of the indexes that was there will now become a local index. So it goes from implicitly global, because obviously a non-partition table only has global indexes. It's going to become a local index. The other index will become partitioned, but not on the partitioning system of the table. It'll actually be globally partitioned on a totally different scheme on created. And also at the same time, I'll actually delete off some of the older rows because I don't want to keep them. They've, say, been archived off into an archive table. So I'll delete them off as well. And I can do that whole thing online and it just works. So that's me spruiking 12.2 for you. The question is, how do we do it before 12.2? Well, we can actually achieve almost all those things as well in 12.2. They're just not as simple, but the functionality is there. What we use is a thing called dbms redefinition. And I thought I'd show you, it's one of those things where it's been around for a long, long time. And I totally concede that when it first came in, I think it was about Oracle 9, it had a few issues and it was quite difficult to manage. The actual API was fairly long-winded. You have to do a lot of work and there are restrictions on how tables were structured. But it's evolved, as with all Oracle features. It's evolved and improved and firmed up over each release. And so I thought I'd show you the demo. So let me bring up a new share. So I'm just checking my little device to make sure that, yep, we can all see that. I'm hoping the font's big enough. Oops, let's go back to here. There we go. OH online. So here's my table called T. It's a copy of DBA objects. I've simply included where object ID not null because that way I'm going to be able to put a primary key on the table, put a primary key on the object ID, and I'll put an index, another index on created and object name. So this is similar. In fact, this is going to be identical to our example we just did in 12.2 that we might be thinking, well, I'm not on 12.2. How am I going to do it in 12.1 and below? So rather than just doing an alter table command, the way dbms redefinition works is you need to create what we call a template table, which matches the target structure. So I'm calling my template table tpar, and as you can see, it's partitioned in the same way that I want the final result to be. This is how we do it using dbms redefinition. The first thing we do is we start redef table. There actually is a routine called can redef table, which you can run as well, which simply says, does a validation as to whether I'll be able to redefine this table, but I've skipped that just for the sake of brevity. So I've started the redefinition of the table. What's going on behind the scenes here is actually using some technology we've had since Oracle 7. We're actually creating, in effect, a materialized view called tpar. It's a copy of T, but in this new structure. Now, the first time you create a materialized view, what happens? We load all the data as of that point in time into the target table. And that's what start redef does. Now, obviously, the moment you do that, that copy is now slowly getting out of sync because the reason we're doing dbms redefinition is to allow uninterrupted service to the source table. But just like the way materialized views work, we can have, in effect, have materialized view logs capturing the information on the source table. Now I'm going to do what I normally do. I'm going to add some constraints, a primary key because that was on the source table. I'm going to add a globally partitioned index because that matches the target from that previous alter command. And therefore we've got all the indexes now in place. Now I might choose to run some occasional sync commands to bring my target table up to date, but this is obviously a very simple demo. Here's the nice thing that came in, probably about Oracle 10, Oracle 10.2. Rather than you having to do all the work in terms of understanding all the things like grants and privileges and triggers, there's a nice simple routine copy table dependence that will go and find all the items on the source table, if it had triggers, what grants it had, etc., and actually copy them over to the target table. And once that's done, I can run this final command, which is a finish redef. Now, unlike 12.2, this last operation will take a small lock on the table because what we're doing effectively here is swapping the dictionary definitions for our target table back with our source table such that we can rename all the objects, underlying objects in the table itself, such that it now becomes the table called T. So let's head back to a new share. So it can be done. It can be done. You can actually use dbms redefinition to achieve just about all the same objectives you can at 12.2. As you can see, it's a bit more of a convoluted approach and an API-driven approach, but it can be done. Now, people say, well, yes, but that's obsolete. When I get to 12.2, I'll never need to use dbms redefinition again, right? It probably will no longer be a useful function. Maybe it'll get deprecated, etc. Well, no, there's actually another use that you won't be able to do in 12.2 using just an alter table command, and where dbms redefinition is actually still really, really cool. Sometimes when we have tables, we want to do huge operations, huge massive operations like massive updates, massive inserts, etc. Or we may want to change the structure of a table, hence the term dbms redefinition. So sometimes it is more efficient to use DDL than it is to run DML. And sometimes we want to change the structure of a table. I'm going to do a demo that does both here, but I'll talk about how each one can be served by dbms redefinition as we go. So here's an example. I'm saying fixing up some name data. And so let me fire up another SQL Plus session. This one's called OH Big Update. I'll remember that so I don't forget. So this will take a few seconds. This one's going to take a little while to actually set up because what I'm doing is I'm creating a list here of 1 million random names taken from some data I've got stored locally. So as you can see on screen, I've picked myself a whole stack of names, which are just effectively random forenames and surnames. Now that might be all well and good, but the requirement might be, well, I generally don't want to just have a single column for names. I often want to have a first name and a last name. I want to be able to split those columns up. Now, rather than jump straight into redefinition, I want to stress that there are other options you can use to tackle this. Now, before I do that, I'll create a table called tbase as a copy of T as it is now, because we're going to do some work on it, and I want to be able to get back to this original table without putting you through that 25-second wait again. So here we go. Here's the data. You can see effectively now, I've lost a row. I've done a clear screen too fast. Can I scroll back? No. Oh, that's a disaster. Okay, you'll see now that magically T has 2 new columns. What I didn't show, unfortunately I've cleared the screen too fast, is I added 2 virtual columns to actually capture, to split the full name into first name and last name, just using the generated as clause to get the virtual columns. I'll have to fix that script when we redo this for the video. Now, in a lot of cases, that's all you need to do, in the sense of, yes, I've got 2 columns now which are effectively generated on the fly from that source column called full name. There are some issues potentially here. Number one is those 2 columns are obviously only read-only. So I can't go update and change the first name. I can't update and change the last name. I can only update the full name, so I have to manage that. The second issue is, obviously, unfortunately, I can't show it because it's disappeared off screen. I'm doing a little bit of jiggery-pokery here with substring and in-string, etc., to identify and isolate those 2 elements. That might have a significant CPU server cost when I'm actually doing this for, say, 1 million rows or 1 billion rows, etc., especially if I'm doing where clause predicates and the like. Maybe I actually want to instantiate those full valued columns onto the table. So let's drop those 2 columns. They were created as virtual columns. And let's actually add them as physical columns. Now, obviously, I need to now populate those 1 million rows. And hopefully now you can see these were the 2 actually substring commands I was using to generate my virtual columns. But now this time I'm doing a straight out update. And already we can see this is not a trivial operation. In fact, as I sit here and try and make idle conversation, you can see this update is working and working and working. It might take a little while because obviously we're running this while the Zoom conference is running, which is recording video and burning my CPU as we go. But there's our 1 million rows done. Obviously that's fairly expensive, but you think, well, the job is done now. I'm done, right? Well, not really. Having done that, having updated every single row to a much bigger version of the row, it's got 2 new columns. Out of those 1 million rows, you can see over 600,000 of them are now chained. Or in fact, they'll be migrated. What does that mean? We spoke about it in the last office hours video. They couldn't be put back into their existing place. They've had to be moved somewhere else. That might have a tremendous impact on index lookups for those particular values. So having spent all that time doing an update, I now have to do a reorganization anyway. I have to reshuffle all the rows to actually bring them back into the table into a nicely performing operation. So even though I sort of just did a DML with an update, I ended up having to do a big DDL anyway to reshuffle all the data. And that leads us onto this thing of maybe we don't, maybe if we're going to have to do a big DDL on all the rows, in fact, you can see that after the alter table move, all the rows are no longer chained or migrated. And so we're back to a nice working table. But since we have to do an operation on the entire table anyway, maybe we can do the update as part of that. So let's get rid of my table called T, and as I said, reinstantiate it from the table called T_base. So that's my base table now. I've had the primary key just as before. Let's now use dbms redefinition to achieve the update statement. Now that sounds a bit strange because redefinition sounds like I'm only doing structural changes, but we can actually use dbms redefinition to perform an update to this new data. So here's my interim table. I need a template table, as I said before, to do dbms redefinition. It's got the 2 new columns, first name and last name, on it. Here's the cool thing with dbms redefinition. I can define what's called a column mapping. So I've got a variable there called colmap, lcolmap, and I'll highlight it. You can see I've actually got 3 expressions. And what I'm doing there is telling the dbms redefinition subsystem that when I go from the source table to the target table, those 3 columns are going to be populated using that expression, those column expressions you can see there. So full name simply gets copied over, and then the other 2 columns get copied over with those 2 substring columns. I then do a start redefinition on the table. I can then add my primary key. I'm filling in the blanks on my indexes. I then finish the redef on the table, and there we go. There is my table, but redefined with two fully populated columns. They're no longer virtual. And if I analyze t-compute statistics, you'll see there is no migrated rows. So it was fast. I didn't have to do a big update. It was a nice, effectively efficient batch operation. And I managed to restructure and do an update on my table without actually having to force a big alter table move at the end of it anyway. Didn't get any migrated rows. It's all win-win. It's fantastic stuff. So don't just think about DBMS redefinition as being, oh, it's only relevant if I'm changing dramatically the structure of a table. You could use this to, for example, do a large update without having to have that large cost of DML. There's a syntax I didn't show here, where you can actually sort the values as they're being copied over. So if you haven't got attribute clustering in Oracle 12.2, once again, on earlier versions, you can use DBMS redefinition to actually resort and hence improve the clustering on your data without having to take it away from the users. Topic number 3. Oh, the time is running so slow. Well, the time's running so fast, I'm running so slow. Dropping an index before 12.2. So first of all, the reason I brought this topic up is I have to apologize because I obviously got it wrong in terms of the talk I did on 12.2, because I had a number of people contact me after the Indian event saying, oh, this new 12.2 feature means I just have to look at this particular database view, which we'll cover in a second, and that tells me if I can drop the index. No, 12.2 is good. It's a lot better than previous releases, but this is the key slide. I stress, this is perhaps my own defense. I put this slide in every presentation I made about indexes in 12.2. The new information we give you in 12.2 is to help your brain, not replace it. It's to augment the decision-making process, not just say, yep, this tells you yes or no whether you can drop an index. And here's the problem. You have a table called sales, and if it's got a sales, it's probably got a primary key, because most good tables have a primary key. But you might want to do queries by customer. So you'll have a customer index. And then you might want to query, for example, this week's sales. So you'll probably have a sales date index. You might want to query by product, and then you'll have a product index. And you can see how these things occur. As each query requirement comes up, more and more and more indexes get created. And often they're like what I call rush jobs. Someone says, I've got this end of month process. It's running really slow. Here's the worst query. And rather than redesign the table, redesign the query, maybe the quick and dirty fix is, look, let's put an index on that solves that particular problem. And of course, then 6 months later, you're going, well, which ones of those are still used? And that's the big challenge. Now, in 12.2, we gave you this thing called DBA index usage, which I've spoken about at length before, so I'm just going to fly through this one very quickly. It's really cool in the sense that it gives you some really nice metrics in terms of the total number of times the index was used, how many rows were accessed, some basic histogram information to give you a broader set of information as to make decisions. And the key one is the last used. When was the last time this index was used? That's all inputs into actually deciding whether you can drop an index. But two counterexamples that hopefully show you that just relying on that information is not good enough. Even in 12.2, I stress that if you've got that view in 12.2, even there, I can give you two counterexamples which prove to you that you need to have your DBA thinking cap on before you just go drop indexes. The first one's a no-brainer. Foreign key locking, as we know, to avoid certain kinds of locks on tables, we might need to put indexes on the child tables that refer back to a parent. If those indexes are present, the need for them to do foreign key to avoid excessive locking is not picked up in that DBA index usage table. Obviously, if you use that index in a query, then yes, it will be picked up. But if it's just there to prevent additional table level locks, it's not picked up in DBA index usage. So you still need to be able to look at the database and look at, for example, DBA constraints, which actually has a index name column, which tells you which indexes are used to implement or are used to implement internally the validation of a constraint. So you can look up your foreign key constraints, and those indexes, you can't really drop them unless you're positive you're not going to have the foreign key locking issues. The second one is the fact that index structures also contain index statistics. And I've shown this demo from people before. Here's a table called T1, and here's a simple query, C1 equals 12 in there in blue, and C2 equals 12. And so we know in advance that the answer is 200. So no magic here. We know that that particular query returns 200 rows. The question is, what does the optimizer think? Well, the optimizer's miles out. It actually thinks that it's 4 rows. And as most of us know, the reason for that is the optimizer doesn't store statistics on the correlation between columns. It knows how many rows of C1 equals 12. It probably knows how many rows of C2 equals 12, but it doesn't know the correlation between those two columns. What if I put an index on those two columns? Well, if you look there at the rows column in the execution plan, now the optimizer has got the result or the estimate spot on. Now, but key thing here is look at the actual plan. It didn't end up using the index. It was still going for table access full. But what it did do is use the statistics on the index to come up with a really good rows estimate. So if I was to drop that index as a DBA because it didn't appear in DBA index usage, even in 12.2, then I might actually make this execution plan go bad because I'm no longer giving it good statistics. Now, obviously, I could create extended statistics to handle the correlation between those values and then drop the index. But I'm just stressing the fact that just because the index data suggests in the DBA index usage view in 12.2 that an index can be dropped, doesn't mean you can just drop it. So back to 12.2. What are the pre-12.2 options? Obviously, you don't get that data at all in 12.2, in 12.1 and below. So what do? Or perhaps a better way of saying it is, even if I have DBA index usage in 12.2, as I said, it's not 100% perfect. It's not going to be ideal. It doesn't complete the source of knowledge for whether making that decision on dropping. Maybe these options here can help you augment that information. So the first one you can do is index monitoring. Now, this is the thing that probably DBA index usage is in time to replace, but that still doesn't mean you can't take advantage of it. And it's pretty simple. If you're on 12.1 or below, you simply do alter index monitoring usage, and that will put a row in the $V object usage table. A quick thing here, which I forgot to mention when I was in India, is the $V object usage view is not your sort of run-of-the-mill $V table. It actually is bound to the schema. So if I need to be in the schema that actually has turned on monitoring for that particular index to actually see it, it's not like a $V view where you can see everything. But when I do alter index table PK monitoring usage, you can see it appears there, it's monitored, yes, but its column of use says, no, I've not used it yet. I then go ahead and do a query on effectively that column, and guess what? It sets monitoring equals Y. Or sorry, used equals yes. But that's it. And this is why we've effectively re-engineered the whole thing in 12.2. That's the only information you get. So how can I use this? Well, that's of some use. Obviously, it's not fantastic, but it's of some use. But what you could do is you could extend this operation yourself. Once an index says it's monitored, once an index has been detected as being used, that's it. It's set to yes. It will never go back to no. But what you could do is you could, for example, collect, say, at 9 a.m., alter index monitoring, and then wait for a while and see all the indexes have said used equals yes. Now you can go through and turn them all off again. And then effectively you can now run for say another 30 minutes and then collect it again. This way you can actually collect over time which indexes are being used rather than just having that one indicator saying yes, at some stage it was used. Now, I want to stress here that if you're doing this, you want to do it not overly frequently. It might be say 9 a.m., turn on monitoring, whichever one's come on at yes, maybe it's say 10 a.m., turn them off again, etc. The reason for that is every time you change the monitoring to yes for an index, what we do is to do our best chance at actually collecting that information for you. This is from Oracle 9 onwards. We actually say the next query that uses that index will do a hard parse. So every time you flick the monitoring switch on, you're going to have a little boost in hard parsing operations on your database. So be aware of that. It's not something you're going to say, let's flick monitoring between yes and no every 30 seconds because you're going to set up a massive parse storm for yourself. But that's one option. That's option number one. Obviously, I said all the existing drawbacks are there that we've spoken about in previous office hours sessions and some of my talks on 12.2. It's a reasonable mechanism, but nowhere near as good as DBA index usage. The second one is, well, rather than seeing if indexes are used, go look for indexes and just see if they could be redundant simply by definition. Now, what do I mean by that? Let's look at this table here called T. It's a copy of DBA objects. It's got a couple of indexes on it. One, IX1, is on the owner column. And the second one, IX2, is on owner, object name. Now, an index like that, we can pretty much know that if I did select star from T where owner equals Scott, then if the first index IX1 didn't exist, then the second index would be sufficient. I could still use the owner column because it's the leading column in the index. And obviously the second query, select from T where owner equals Scott and object name equals M, that could definitely use the second index. So if an index simply is effectively a subset of what I call a longer index, or an index that has more columns. So if the leading columns of one index are totally contained within the leading columns of a second index, you could make an argument that that first index could perhaps be dropped. Now, I'm stressing the perhaps here. So how do I identify this? Well, it's actually pretty easy to do as long as you're on 11 and above, because we have the listag function. So what I can do with listag, you can see in the query there, is for each particular index, I can produce a concatenation of all the columns in the index. With that now, so effectively assuming that's I've got that result set, I can now effectively do a join of that result set to itself to see, and you can see there on line 24, what I'm doing is this saying, is the superset columns for an index simply the beginning of some other index? Is some other index totally contained in the leading columns of the superset index? And we can see there, I got the result there, which simply said, in my table, in my schema called Scott, index number 1 is actually supersetted by index number 2. But, and this is why I said perhaps, yes, it is true that by definition, one index there, the second one with 2 columns, could do the job of both. That doesn't mean it's a guaranteed proposition. Let's look at this example. Here's my 2 indexes still in play. Select star from T where owner equals Scott, and I'm using index number 1 that had the column of just owner in the index. I drop that index thinking that my other index is totally fine and is going to do the job, but look at the execution plan I got. I actually ended up with table access full, even though index number 2 on owner and object name is still present. The database costed it differently. Just because it had the same leading column doesn't mean it'll be costed the same way, because the index size is different. If it's got more columns in the index size, the index clustering factor, the index distribution is different. In fact, if I force a hint in there, we can actually see that the cost there, if I flick back one value, the cost there was 424 for the full table scan. And when I forced it to use the index that I thought it was going to use, it came costed out at 1,013. And that's why it went for the full table scan. So as I said, another tool in your toolbox is looking for redundant indexes to see if maybe I could drop an index. It doesn't guarantee you that you can actually do it. As I said, be careful. That's a key thing. Whenever it comes to dropping indexes, if it seems obvious, that's when you want to pause for a second and be careful. The third option you have is segment statistics. There's a view called $V segment statistics, which captures a whole lot of information at the segment level. And what information does it catch? It catches things like database block changes, logical reads, a whole stack of other stuff as well, especially if it's in the in-memory store. And so picking out information at a segment by segment basis is once again an input to information about how you can maybe track where the indexes are being used. So let's think about an index. Obviously, if I insert, update, or delete rows, then the index has to change. Now, to get to a particular value in an index, a particular row, a particular entry, I'd obviously have to start from the root, go down to a branch, and then find the actual leaf. Now, I'll keep this simple and assume it's just a unique index, so we're just going to find the one leaf. With a range scan, things get a bit more complicated. Now, for a query, so for every time we change a row, we're going to do maybe 2 or 3 reads on the index. Obviously, when we query an index, we'll be doing the same operation, root, branch, leaf, but lots and lots of queries means lots and lots and lots of traverses down that index. So we're making a lot of assumptions here, but we could look at $V segment statistics and say, if the number of block changes is say half or maybe a third, somewhere around there, of the number of reads, we could make an assumption that the only operations we're doing are these kind of ones. So every time I do a change, I'm doing 3 reads. So for each change, 3 reads. If the number of changes is roughly 1/3 the number of reads, it's an input to the case of maybe this only being used for DML and therefore not being any beneficial for queries. Obviously, if it's doing this kind of operation, we're seeing thousands and thousands and thousands of logical reads and not many block changes, then we have confidence that the index is in active use. as I said, I'm making a lot of assumptions here because obviously we don't control how $segment stats is populated. We don't know whether it's every single captured change. We don't know whether it captures, for example, the walking down the root and the branch, or whether it just captures changes on the leaf or just queries on all. All those things are sort of up for debate. So it's important, as I said, it's another input. I think I might have put, be careful. It's another input into our decision-making process. And we got another one, which is using $SQL plan. Obviously, if I'm using an index in a query or even a DML, it will generally appear in the execution plan. So what I could do is query something along these lines. Go get the object name. I'm looking at the blue text here. Go get the object name and count star for every single object I can find in SQL plan. And I'm just doing a simple outer join to my list of indexes. If I get a hit, then I know that that index name definitely is currently in at least one execution plan in SQL plan. And therefore that, it leads me on to having more information about how to actually make that decision. But of course, that information in SQL plan is transient. The moment an SQL gets aged out, it's no longer there. Now you could, for example, go data mining in DBA hist SQL plan if you're using things like AWR. And once again, as I said, it's inputs. Be careful. It's just helping you add to the pyramid of information that's going to help you make a decision. In all cases, if you've gone through all those steps and decided, yep, I am going to drop that index, please do this. Make it invisible first. That's available since Oracle 11. That keeps the index and keeps all the index content. And what's more, as DML occurs, keeps that index still up to date. It just makes it unavailable to the optimizer. This is what I call the see if someone screams option. You make it invisible and you wait for the phone call. And if no phone call comes, maybe wait for a month. I stress, have some patience. After all, just wait, and then maybe think about dropping it. And I will say one last thing on indexes in terms of dropping them is make sure you have a reason for dropping it. It's very easy to get stuck into well, that index might not be used, so I should drop it. But if it's not having any impact on your DML, your inserts, update, deletes, and it's not having any impact on your queries, then yes, it might be wasted, but who cares? Who cares about a few gigabytes? Am I only on number 4? Oh man, I'm hopeless. Okay, public and private synonyms. What are they and how do they work? It's pretty simple. So this one we'll get through nice and fast. When I connect as a username called Connor, it's my current schema. That makes sense. I connect as Connor, therefore my schema is Connor. So when I do select star from emp, what I'm implicitly doing is I'm trying to first try stuff in my schema, Connor.emp. That's the thing I'm looking for first. Now, you don't have to be, your schema and your user do not have to be actually in alignment. I can actually run alter session set current schema equals John, for example. Now, what that does is it doesn't change who I'm connected as. I actually am still the user called Connor, but now it's simply changing where I look first. So now when I do select star from emp, I'm doing select star from john.emp. That's the first place I'm looking. Now, none of that has anything to do with synonyms so far. But once we decided which schema we're looking in, then we try resolve that name, as in what is that thing? So when I do select star from emp, I need to actually work out what emp is. I need to resolve it as an object. Now, I keep using the word object here because it might not necessarily be a table. It could be a private synonym. So let's have a look at what that means. A private synonym is a synonym that exists in your schema only, your user only, which is used as a means of redirection to maybe some other name. So it could be something like this. When I do select star from emp, there could be a private synonym called emp, which actually simply points to a different name in the same schema. My real table called emp. It could be a private synonym that just points to another object in your schema. It doesn't have to be a table. It could be a synonym that points to a view in your schema. So as I said, it could be a view. And it doesn't have to be in your schema. It could simply be a synonym that points to a view in another schema or a table in another schema or anything like that. So in this case, emp actually points to a view in the Scott schema. It could even be a synonym which simply points to another synonym. And that synonym could be in your schema, could be in someone else's schema. So the list of synonyms can simply cascade onwards continually. The key thing is this object is a synonym called emp and it's owned in your schema, and therefore it is a private synonym. What if it's none of these things? What if you can do select star from emp, and there's nothing in your own schema called emp? No synonyms, no views, no tables. Well, what we do there is we effectively roll up to a single special user. There's actually a user called public, and it holds things called public synonyms, which simply says, if I can't resolve an object name in my local schema, maybe there's a synonym that sits across the entire database that then points to such thing. Did I put? Yep. So here's an example where I use a special DDL called create public synonym, which really behind the covers would be doing create synonym public.emp for example, something in the Pete schema called his table called employees. Key point here. The question that came in on the Ask Tom office hours was, and how does this affect privileges? This has nothing to do with privileges. A synonym simply tells you where to finally look. You still need to have access to that final object. So if I have no grants on some object in some other schema, yes, I can have a synonym that points to it, but it doesn't give me any privileges to actually refer to it still. Synonyms can point to non-existent objects. They can point to objects that you have no rights on, and obviously point to objects that you have other rights on. Maybe because I'm running out of time, there's another discussion we'll have maybe in the next office hours about what are my thoughts on public synonyms versus private synonyms. In a nutshell, I hate public synonyms, and we'll talk about that maybe in another office hours. Number 5, bypassing force logging. Now, a bit of background. What is force logging? Well, most of us in DBAs have things called standby databases. And if not, you should have one because they're awesome. They're so powerful. You can do all sorts of cool things with them. But the way a standby database is kept in sync with the primary is by the transmission of redo. As changes occur in the primary, they get transmitted by the redo logs over to the standby, and the standby is kept up to date in effectively doing a database recovery in real time. The problem, of course, is one of the things that we support in the database for some time is the ability to do operations that don't generate redo. I could do alter table ask tom.t no logging, and then I could do a big insert, a direct mode insert into it, and none of those changes will be logged. Now, that's a bit of a drama when we come back to trying to get that information over to the standby database. And in fact, the database will even log it in Vita data file. It'll say, yes, you've done an operation. It calls them unrecoverable, which is simply a historical name. But it actually says, well, you've done a no logging operation on the 17th of June, and therefore that data is not completely logged. And what happens? You've now got some gaps. The information that is being sent over to your standby is incomplete because that big chunk of rows we just created in the asktom.t table were not logged, and therefore the logs didn't make it over to the standby. And ultimately, if you actually try query that table one day on the standby, you get an error because that information simply was not sufficient to keep the standby up to date. Now, one of the awkward things there is, and it's actually true, but the error we report back is that you've actually got a database corruption. And of course, that's not fun for DBAs because what if it's a real corruption? I mean, this is a real corruption, but it's due to a no logging operation. But as a DBA, what you don't want to do is every day wake up to an error message saying you have a corruption in your database, because it may have been a corruption due to a no logging operation. It may be a genuine corruption due to, for example, an OS problem or a disk problem, and you have to make that decision every single day. That's a stressful time for all of us. So we invented this back in Oracle 9, force logging. Alter database force logging, it's pretty simple. We don't care if you try to do a no logging operation, we simply ignore it. Everything is logged, and therefore the redo is always going to be complete. The question that came in was, how can I bypass that? Well, that's a bit of a weird choice to me because the only reason you put on force logging is because you're saying it's not worth my while to bypass it. It's, there's no option to bypass force logging because that's why it's called force logging. The force should be the hint there. So what are your options? If you've got, why would we want to bypass logging? Typically because we're generating a lot of redo for, say, a big bulk operation. Let's say I'm doing a big bulk load. The first operation is, this may sound weird, is have a chat with the person that set force logging. That might be a colleague of your DBAs. If you're a developer, it might be your DBA in another room, but, have a dialogue. It might well be the case that you turn off force logging for a small part of the operation, and then do your bulk load if it's a one-off, and then turn force logging back on. But at least have some communication with your DBA. In 12C, it's actually not too hard. And so you might be able to convince the DBAs on your team to say, we're not going to run force logging because if my standby stops, unlike back in the old days, it's actually not too difficult to actually reinstate the standby. It's simply cancel. You can see that the commands are actually, 7 lines. We simply cancel the recovery, recover database from service. That's a really cool thing in 12C onwards. Restore the standby control file, recover the standby, and off you go. You don't even know which data file. It's just going to take care of looking after the ones that are needed. That's pretty cool. In 18C, it's a one-liner. How cool is that? Just recover standby database from service. So maybe you could sacrifice the forced logging in order to actually take advantage of these easy commands to actually reinstate the standby and pick up just the changes required. Maybe that's all you need to do. Second option is maybe transportable tablespace. If you can't have forced logging turned off on your primary, maybe you create a temporary database, just a small database that doesn't have forced logging on. Do your big database loads into there, and then transport the data files to both the primary and the standby. Because then when you do the data pump import, which actually just copies the metadata into the primary, that will actually populate obviously over to the standby because metadata changes will be populated via redo. And therefore you've effectively transported a table space of your bulk load data into both nodes without having that huge logging overhead. The third one is if it's part of a load process and you need to use that table just in the same session, maybe a global temporary table is all you need. Maybe that'll cover off the option for you as well. Oh, it's 8:57, man. I only got 5 of 7 done. Let me just pause the share for a second. That's all I had for the end. So let me finish off this session. As I do every single month, I apologize for not getting through all the questions, but they will be put onto the queue for next month's as well. And obviously over time, I'll just get more and more behind. In all seriousness, what I'll try to do is those remaining few questions, I'll try construct a video. As most people know who've been on Ask Tom Office Hours, I do a video highlights segment, cut them up, each question up into video segments, which go on my YouTube channel, which you can see the link there below. So what I'll do is I'll take those remaining questions and try to turn them into YouTube videos as well, so you can catch up on them. Thank you very much for attending. Please keep an eye on the asktom.oracle.com/office hours page. We have so many office hours coming along. I hope you've enjoyed this session. And well, I'll probably see you in a month. If not, I'll see you hopefully in South America. Thank you very much for your time, and we'll see you all again soon. Bye, everyone.